Welcome. This is the SAT practice test number 7, section 3, math test, no calculator, 1 page at a time with hints and tricks. So if you would like to try these 2 problems without any hints, please pause it now. I'll go ahead and add a couple hints for each of these problems and then work through them. So for number 11, if you're looking for a hint, it would be a couple reminders. One, that if you have a negative exponent, it can simply be changed to a positive exponent if you switch it to the other side of the fraction, okay? And then the other one is to remember that if you have a fraction for an exponent, it can be converted to radical form. It can be converted to a root. So in other words, the y in the numerator to the power of 1/2 is the same as the square root of y, right? So square root would be second root square root of y. So you could do the same thing with the x in the denominator if necessary. Hint for number 12 would be to either graph this, right? This is just function notation. So if you have a graphing calculator, you could very easily graph this to see what you're dealing with. Another hint would be the formula for the axis of symmetry. So the axis of symmetry is x equals negative b over 2a. Okay, so go ahead and give those a try if you haven't already done so. If you want to hit pause, and then we'll go back through step by step. Okay, so for number 11, we're just asked for which is equivalent to this expression, and they're telling us x is greater than 1 and y is greater than 1. So if I go ahead and get rid of those negative exponents, because none of the answer choices have negative exponents. Again, you can change a negative exponent to a positive exponent by putting it in the opposite numerator or denominator of the fraction. So if I take this x to the power of -2 that's originally in the numerator, if I send it to the denominator, it will become x to the power of +1. And likewise with the y to the power of -1 that's originally in the denominator, I'm going to send that to the numerator. So what that would look like is I would keep my y to the power of 1/2, but actually let's go ahead and make that the square root of y that we talked about in the hint. And then I'm going to have y to the power of +1 move to the numerator. I'm going to have x to the power of +2 in the denominator. And I'm going to go ahead and switch that x to the power of 1/3 to the cubed root of x. And let's see if that matches any of our answer choices. Yes, it does. It is choice D. Choice D. We don't even have to go any further. Okay. Next one. So we have a quadratic function. They're telling us that the graph is a parabola. Which of the following intervals contains the x-coordinate of the vertex? So quick little review. If you have a parabola, the axis of symmetry is that vertical line that cuts your parabola in half to make it symmetrical. So that's what we have the formula for, which is where the vertex is, right? So the vertex is the minimum or maximum of your parabola. So we would need to know the axis of symmetry in order to have the x value for the vertex point, okay? But we're actually asked to focus on the x coordinate anyway. So if you graph this, again, you could probably just see it from your graphing calculator. Without graphing it, I'm gonna have to convert this to standard form. So I'm going to take my f of x equals x plus 3 times x plus 1 and go ahead and multiply that or use FOIL. So I'd have x squared plus x plus 3x plus 3 simplified to x squared plus 4x plus 3. And if I go ahead and use that axis of symmetry formula, I have a b value of 4, so that would be -4 over 2 times an a value of 1. And that gives me -4 divided by 2 gives me -2. So the x value of the vertex is -2. So which one of these is the correct interval? It would be choice B. Choice B. -2 is between -3 and +1. Okay, so those were problems 11 and 12 from SAT practice test number 7, section 3. Please look for the next set of problems, the next page, numbers 13 through 15.